Ready-Made Maths YouTube channel. Teaching assistant and teacher training in mental mathematics. Today's arithmetic for day 3 is round and adjust.
Good morning and welcome to day 3 of the Ready-Made Maths YouTube channel, Mental Arithmetic Strategies. Over the past couple of days, we've looked at the first 2 strategies. On day 1, we looked at lots and lots of different ways of using number bonds to help make mental calculation much easier. Yesterday, on day 2, we looked at the strategy of double and adjust, where we use near doubles again to simplify calculations. Today, we're moving on to the third strategy, and if we can look at the board over here, where we can see a series of calculations. Today's strategy is round and adjust. The calculations that you can see on the board there, 17 add 9, 48 add 19, 64 add 39, and so on, all have something in common. What we're going to do now is just pause the video, just take a few seconds to have a look at those calculations. What do you notice? What's the same about them all, and what's different? What you should hopefully have noticed from each of those calculations is that one of the numbers is very close to a multiple of 10, or a multiple of 100, or in this case, to a whole number. They all end in 9, or in this case, 8. So each one of those calculations can actually be worked out by using the strategy of round and adjust. And that's what we're going to look at today. This strategy is one of those that I think is really, really important. I do a lot of work in primary schools where I do an audit of children's calculation skills. Just before we broke for the current situation, I was in a school, several schools actually, giving these sorts of calculations to children in years 2, 3 and 4. What I tended to find was when I gave children in year 2, 17 and 9, 99% of them did it on their fingers. When I gave children in year 2 or 3, 48 plus 19, generally they'd either write it as a column method or they'd do a partition. Exactly the same with this one. 64 add 39. The vast majority of year 3 children went straight into a column method. What was really surprising was that very, very few children, and we're probably talking only 1 or 2%, actually spotted that there's a much, much easier way to do each of those calculations. As I moved into year 4 and into year 5 and gave calculations such as these, again, it was 100%. These ones, not a single child was seeing that 2,998, there's a much quicker way to do that than putting it into a column and just adding it up straight away. What we're going to do over the course of today is have a look at some visual resources that support the idea of rounding and adjusting. We're going to play a little game that also involves that skill, and then we're going to come back to the board and the Ready-Made Maths number wall at the end, and we're going to do some little bits of practice of the round and adjust skill as well. We're going to begin with a tasty little problem. What we've got over here are 15 cakes. And we've been asked, can we bake 9 more cakes? How many will that give us in total? Well, obviously, the way that many children will see to do that one is, well, we've got 15 cakes, we need another 9. Well, let's just count 1, 2, 3, 4, 5. That's 5 cakes, which now gives us another box. We're now up to 20. We'll bring a new box out. We'll keep counting. 6, 7, 8, 9. And that gives us a total of, let's just make sure, 24 cakes. Now that's obviously one way of doing it, but very, very inefficient just to keep counting on 9. We do end up though with the correct answer, which is 24. Back to our original 15 cakes, and we've got another tray of cakes over here. Now this tray of cakes has got 10 in. What do we know about the number 10? Well, we're being asked to add 9. What do we know about 10? Well, if I take the 1 out, that actually gives us 9. So we could find a different way of working out 15 add 9. What we could do is we could add a brand new tray of cakes and put it over here. But rather than taking the 1 from there, let's just take the 1 from here. And we end up with 24. What we've done is we've added 10 and took off 1 because we know that 9 is 1 less than 10. That way has got to be far, far quicker than individually counting all of the cakes. Back in the bakery, and the baker's been hard at work. We've now got a lot more cakes. Have a look at the way that they've been set out. Can you see, just really quickly, we're going to pause the video just by having a quick glance. Can you tell me how many cakes and how you know? You should hopefully have seen 3 10s and a 7. And that 7, as we've shown all week, we've set it out 10s frame style as a 5 and a 2 so that you can instantly see it. been saying this all week, but if we'd have had the 7 like that, you'd have had to actually just count the entire thing. By arranging them in this particular style, we can see straight away 37, but we can also see 3 less than 40. So again, it's a really, really nice way of setting out apparatus. Even if we haven't got the egg boxes to put them in, if we'd have arranged the cakes that way, again, we'd be able to see the number really, really easily. Now again, we're going to add 9 to that number. Bearing in mind what we did before, what do we know about the number 9? We know the number 9 is 1 less than 10. So I could just put the 9 there, but then we're going to make it a little bit complicated. So what we'll do as before is we'll put the 10 at this end, and rather than taking the 1 out of there, we'll take the 1 out of here. So we've added 9 by adding 10 and subtracting 1, giving us a total of 46 cakes. We can now see 3 calculations, this time set up more traditionally with base 10. At the moment, we can just see the numbers. Again, set out 10's frame style. 26, which is 25 and 1. 48, 40, 5 and 3. And 79, have a look at the 79. You can see the 70 is a 50 and a 20, and the 9 is a 5 and a 4. What we're going to do to each of those is we're going to add 9. So we're going to start off with the 26. I'm going to get 9 counters from over here. Well, 9 ones. I'm going to take my 9 ones and I'm going to add them on the very, very conventional way. Let's add on our 9. 1, 2, 3, 4. I've added my first 4. With our number bonds makes 30. What we can now do is exchange our 10 ones for a 10. I've added 4. Let's keep going. 5, 6, 7, 8, 9, and we've created another 5. We've ended up with 35. Could we have done that much quicker? Without a shadow of a doubt. What we could have done is we could have kept the 26 together, and rather than adding 9, what do we know about 9? It's 1 less than 10. So what we do is we add 10 and take 1. 26 and 9 is 35. So much quicker. We move on to the second calculation. 48 add 9. Again, I could add my 2 if I wanted to. Add my 2 over there, and then get another 7. 1, 2, 3, 4, 5, 6, 7. So I've added 9 in total. Put those on there. Again, I can exchange those 10 ones for a 10, and we have a total of 57. But again, going back to the quicker way to do that, we have 48. 48 add 9, add 10, 58, take 1, 57. Much quicker, much simpler, very easy to visualise as well. With the third calculation, I'm just going to look at the simple strategy. 79, how do we add 9? Add 10, take 1. 79, add 10 is 89, take 1 is 88. I'll just shift that over there so you can see the 50 and the 30. 79 and 9 equals 88. If we start to adapt that strategy initially as a visual strategy, eventually, quite quickly, it becomes a strategy that children can use in their heads.
As we've just seen, it's really important, wherever possible, to give children a visual image first before they actually start to develop a mental arithmetic strategy. That means they've got the understanding before they start to use the strategy as part of their mental calculation. With rounding and adjusting, we've just seen adding 9 initially with the 10 frame approach. We can see the 15 there, and we can add the 9 by adding 5 and 4 in individual ones, or just add a 10 and subtract a 1 to give us a total of 24. That was developed into the use of base 10. And we can see 3 different numbers here, 26, 48 and 79. How do we add 9 to any of those? As before, we add a 10 and we subtract a 1. So we can see for each of those calculations how quickly it can be done just by using that strategy of round and adjust. Also, take note of the layout that we've been discussing all week. How do we see that total of 57? We see 5 10s, a 5 and a 2. How do we see the total of 88? We don't see the 8 10s together. We see a 50 and a 30, and we see the 8 as a 5 and a 3. We're going to continue to use that approach throughout all of the training that's coming up, so it becomes something that becomes more natural when we're working with children.
So we've now set up a slightly more complicated calculation where we've got to add 9, add 9, add 9, and add 9. Imagine doing that in ones. I've got my daughter Lydia who's going to help out with this one. Lydia, what have you brought to help us out with this one?
I've brought 4 10s.
4 10s, right? You explain what you're going to do then.
So for each 9 I'm going to add 10 and take 1, like this. For the first one. add 10, take 1. And that leaves us with 37.
Brilliant.
For the next one, add another 10 and take 1. Oops. That leaves us with 46. And you guessed it, add 10, take 1, and that's 55. And now the last one, the last 9, is add your 10, take the 1, because 10 take 1 is 9, and that makes it so the overall 28 plus 9 plus 9 plus 9 plus 9 equals 64.
Fantastic. And can you think of another way that you could do it, looking at what you've just done there?
I think that instead of doing 4 9s, you could do 9 times 4 and then do 36 plus 28.
Brilliant, loving it. We're now at the other side of the Reddy Maths classroom, and this is the 1 to 120 number grid created by Sense of Number. This is a resource that I use an awful lot, because what this does, it shows the numbers 1, not just to 100 like on a standard 100 square, but all the way to 120. But it doesn't just show the numerals, which is what we're used to seeing, it actually shows a visual image of them at the same time. Now if we're trying to develop this strategy of round and adjust, we can take any of those numbers that I've circled and actually replicate what we just did on the table. Let's start with the smallest number, 13. The strategy for adding 9, add 10 and take 1. So if I was just to get a different coloured pen and see what happens, 13 add 10, we can see straight away it is 10 more. You've got 1 10 there, you've got 2 10s here. And we take 1 and we end up with 22. So we've got that diagonal movement really. Add 10, take 1. Over here we've got 1 10 and 3 1s. We've now got 2 10s and 2 1s. Moving over to number 48. Let's try the same thing. 48 add 9. We add 10. We can see there's a 10 more now. It isn't just a numeral moving up. We can actually see the 4 becomes a 5 because 4 10s becomes 5 10s. And then we take off our 1 and that gives us 57. Add 10, take 1. 65 add 9. 65 add 10 is 75. And take 1. 74. 82 add 9. 82 add 10 is 92. Take 1. That's 91. 8 10s and 2 1s. 9 10s and 1 1. So each time we can see that what's happened is the 10s have gone up by 1 and the 1s have gone down by 1 because we've actually really added 1 less than 10. What happens when we get to a number that's almost 100? Well, because this number grid goes beyond the number 100, we can actually see what happens. 97 add 10. Well, we can see there's a colour change there. Why is there a colour change? We had 9 10s, we added an extra 10, we've now got 10 10s, and that's now been replaced with 100. We take away the 1 and we end up with 106. Now, if we were to make that same calculation with base 10, this won't take a second to do, we can get 1, 2, 3, 4, 5, 6, 7, 8, 9 10s. There's our 9 10s. Put those over there. And we'll get our 7 1s. 1, 2, 3, 4, 5, 6, 7. 97 add 10. I'm going to put my 10 down here. I've now got 10 10s. Those 10 10s can be exchanged for 100. We take off the 1 and we end up with 106. We're going to finish our adding 9, rounding and adjusting with a little song that can stick in your head so you can always remember how to do it. What's the strategy for adding 9? Very, very simple. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. Looking at the egg boxes with the cakes in. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. So 16 add 9 is 25. Looking at the base 10. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. So on that one we had 47, add 9 is 56. And finally, over on the board, 79. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. 79 add 10 is 89, take 1 is 88. So whichever way we do, that strategy works really, really well. What we're now going to look at is developing this into year 3 and beyond, and how we take the same strategy and apply it throughout school in Key Stage 2 as well.
The song that you just heard, My Strategy for Adding 9, It's part of the number fun resources that I mentioned in the previous video. I just want to play a little clip of that particular song so that you can see the visual at the same time as the song taking place.
My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. My strategy for adding 9 is simple and it's fun. My strategy for adding 9 is add 10, take 1. 65 add 9. 65 add 10 makes 75. 75 take 1 makes 74. So 65 add 9 makes 74. 65 add 9 makes 74.
As you can see from the visuals and the PowerPoint at the same time, the song is backed up with the base 10 in the same way that we looked at on the previous little video clip. Using something like this is also obviously really powerful with children. If you want to get hold of those, as we mentioned yesterday, have a look at the Number Fun portal. As with many of the other songs, there's also PowerPoint presentations and other resources that go alongside the song. On the PowerPoint here, you'll see the visual of the base 10 has been replaced by an abstract calculation from the sense of number visual calculation policy. You can see the same calculation that we saw in the song, 65 add 9 by adding 10 and taking 1. That progresses into 32 and 47, which are the two other numbers that are used in the actual song itself. Here we can see a standard normal version of a number grid. The one that we looked at in the Reddy Maths classroom was one that contained base 10. This is just the normal version. This is actually the interactive teaching program number grid. We've highlighted there a wide range of numbers. What we're going to do is just ask you very, very quickly to add 9 to any of those numbers or to all of those numbers just while the video is paused. What you should have hopefully done with any of those examples is to add 9, a simple strategy, add 10, take 1. You can see there that although it eventually looks like a diagonal movement, to go from, for example, the 58 here to the 67 here, in actual fact, you're adding 10 to make 68 and subtracting 1. The 10s have gone up by 1, the 1s have gone down by 1, because what you've actually done is add 9. You can prove it by counting on from 58. 1, 2, 3, 4, 5, 6, 7, 8, 9.
This is just a quick little game that you can play at home. It's very, very simple. All that you need is some counters and a 10-sided dice, and you can play this game. The game is called 9 or halve. The rules are really, really simple. You roll your dice. If it's an even number, you halve it. If it's an odd number, you add 9. And you keep going around in a circle, either adding 9 or halving to the new number, until you eventually end up at the number you started with. Whoever says that number wins the first point. The easiest way to show you is to demonstrate it, so we're going to have a little game of 9 or halve. Used a new character, this is Zog. I'm going to put the Zog voice on. He's got a very deep voice, haven't you, Zog? Here he is. And between the three of us, we're going to play the game. Lydia will roll the dice and tell us the first number. If she rolls a 0, we'll call it 10. It's a normal 0 to 9 dice. Off you go, Lydia.
Okay, so I've rolled a 6.
We've rolled a 6. What's half of 6, Lydia?
3.
3. Now that's an odd number, so I've got to add 9. Add 10 is 13. Subtract 1 is 12. And Zog, half of 12 is 6. Oh, that was a quick game. So Zog wins a point straight away. Lucky Zog. Right. Zog now rolls the dice. I'll roll it for him. He'll struggle. He's got the number 10. A half of 10 is 5. Lydia.
So 5 is an odd number. So add 9 is, you need to add 10, take 1. So 5, add 10 is 15, take 1 is 14.
Brilliant. Over to me. A half of 14. Nice and easy one. That's 7. Zog. 7's an odd number, so I'm going to add 9. 7 add 10 is 17. Take 1 is 16. Lydia.
That's even, so half of 16 is 8.
8 is also even, so half of 8 is 4. Half of 4 is 2.
Half of 2 is 1.
And I end up with 1 add 9. For this one, I don't need the strategy because that's a number bond. 1 add 9 is 10, That was the number we started off with. And so this time, I win a point. Unfortunately, Lydia, you've not scored yet.
This is not my lucky day.
Not your lucky day. Now, we're going to move on to adding 19. I'm sure we can imagine when we add 9, we add 10 take 1. What's the next strategy to add a number like 19? What do you think that's going to be? Just pause the video for a second, have a quick think. And hopefully you'll have realised to add 19 is only slightly more difficult than adding 9. Add 19, we add 10, we add 20, and then we take 1. On the board, 36 add 19, 36, 46, 56, 55. If it was 28 add 19, 28, 38, 48, 47, add 20, subtract 1. If it was 97, add 19, 97 add 10 is 107, add 20 is 117, and subtract 1 is 116. What I'm going to show you is a quick fire way of doing this in your head, just using your fingers. So, 37 add 19, 47, 57, 56. So we add 10, we add 20, and we subtract 1. 58 add 19, 68, 78, 77. So we're getting used to just adding 20, taking 1. 32 add 19, 42, 52, 51. Now obviously we could have used that same strategy for add 9, for adding 10, taking 1. We're using it for add 19, which is add 20 and take 1. So really nice strategy. I'm going to use that one for an adaptation of the game that we played a few minutes ago. We're now going to play 19 or a half. So as you can see, we're now going to play 19 or a half. If the number is even, we half it as before. A couple of slightly harder halves coming in now. If the number is odd, we add 19 by adding 20 and subtracting 1. We kick off by using a 20-sided dice. Off you go, Lydia.
Hello. So, our number this time is 3.
Number 3. Add 19.
So it's an odd number, so I need to add 20. So 3 plus 20. So 13, 23, 22.
Fantastic. Over to Zig. Half of 22, Zig.
Oh, half of 22 is 11.
I get number 11. Add 20. That's 21. 31. Subtract 1 is 30. Over to Zog. Easy. Half of 30 is 15. Lydia, 15.
So 15 is odd. So add 20. So 15, 25, 35, 34.
Fantastic. Zig, what about you? You've got half of 34.
Half of 34 is 17.
Brilliant halving, Zig. So I've got the number 17. 17, add 10 is 27. Add 20 is 37. Subtract 1 is 36. Zog, that's a difficult one for you. No problem. A half of 30 is 15 and a half of 6 is 3. So a half of 36 is 18. Lydia.
So that's even. So half of 18 is 9.
Yes. Over to Zig. 9.
Oh, so 9 is odd. So I need to do 9 plus 19. So I add 20, 19, and then it's 29. Take 1 is 28.
Well done, Zig. Half of 28 is 14. Zog. A half of 14 is 7. Lydia.
So 7 plus 20 is 27. Take 1 is 26.
Zig. Half of 26.
Half of 26 is 13.
Over to me. 13 add 19. 13 add 20. 13, 23, 33. Subtract 1 is 32. Zog. Half of 32 is 16. Lydia.
Half of 16 is 8.
Zig.
Half of 8 is 4.
Half of 4 is 2. Half of 2 is 1. You can do this one in your head, Lydia. 1 add 19.
1 and 19 is 20.
Zig, half of 20.
Half of 20 is 10.
Half of 10 is 5. 5, 15, 25, 24.
Half of 24 is 12.
Zig.
Half of 12 is 6.
And finally back to myself. Half of 6 is 3, and that's the number that we started off with. It takes a long time, but it really does get those skills developed.
Just in case the instructions were a little bit complicated or there wasn't time to see them properly while we played the game, I've just left an example of the instructions here that you can look at in your own time. explaining how the game works, and giving at the bottom an example of the numbers that could potentially come up and where the add 10, take 1 comes up. You can see there that we started off by rolling a 7, we'd immediately add 9, we add 10, 17, and subtract 1. 16, we then keep halving, 8, 4, 2, and 1. We do 1 add 9, which gives us a 10. We halve that, because we're now at an even number again, which gives us a 5. We're then back to the strategy again. 5 add 10 is 15, subtract 1 is 14. And finally, we halve to get the number that we started with. Here we can see the more complicated game, the 19 or half, and you can see how many more numbers there are, even starting off with a 20-sided dice. Again, try to show underneath when you would employ the strategy of adding 20 and subtracting 1. There are a couple of examples where you may just do it a different way. Down here, for example, when you eventually get to number 3, you could just go 19 add 3 is 22. Very, very easy. Similarly, when you get to the number 11, although you can go 21, 31, 30, you could quite easily, because of the number bond, straight away put the 9 and the 1 together. So there are various strategies that we can use. But certainly, adding 19 to 15, or adding 19 to 17, or adding 19 to 13, that strategy is definitely going to be the best one to employ. So do play that game at home. It is really good fun, and it does get that skill developed. You can build it up if you want to 29 or a half, 39 or a half, and so on, but they do take an awful lot longer. So having spent quite a while now looking at the development of rounding and adjusting, using add 10 subtract 1 or add 20 subtract 1, can we see a really quick way to do all of these calculations? We should hopefully now be able to look at any of these and answer them reasonably quickly using that strategy. Just spend, I don't know, 2 minutes having a look at those, grab a pen and paper and have a quick go while we pause the video. I'm hoping what you did, for example, for 94 was add 9 to get 104 and subtract 1 for 103. We look over here at 134, 144, 154, subtract 1, 153. Even down with the complicated ones where we cross the hundreds boundary, 499, 509, subtract 1 is 508. If we're struggling with crossing the hundreds boundary, look at how many tens we've got. 49 tens, we're adding a 10, we must now have 50 tens. That's a simple way to think about it. The same with this one here. When we're adding 20, we're actually adding 2 tens. So we can go 594, 604, 614, and then subtract the 1. Or we can say, well, we've got 59 tens. We're going to add another 2 tens, therefore we must have 61 tens. 61 tens are 3 ones, 613. So that's just another thing we could be thinking about as we're doing these strategies. The two that I've outlined in black at the top there are slightly different. 71 add 9, we do not want to be adding 10 subtracting 1. We know that one is a number bond. 51 add 19, we could probably do it either way, but 51 add 10 is 61, add 9 is 70. So we've got to encourage children, although that's the best strategy, generally, if we don't know the answer, adding 19, we've got to encourage them to look for the options when that doesn't take place, usually when the number ends in a 1.
Moving back to the board, we looked at these calculations at the start of the session and said that we'd come back to them later. Once yourselves and children have got used to that idea of rounding and adjusting, how do we add 9? We add 10 and take 1. How do we add 19? We add 20 and take 1. We can soon apply that strategy to almost any number. And again, it doesn't have to end in a 9. That can be extended and advanced to other numbers as well. The first 3 now should be relatively straightforward. 17 add 9, the strategy we've just been practicing. 17 add 10 is 27, subtract 1 is 26. So we can kind of go down there, 27 and then 26. But to be honest, what you'd probably do is you just work that one out in your head and just write the answer, 26. 48 add 19, similar idea. We're going to add 20. If you want to show the jotting, you just put add 20, subtract 1. Just so the children can see what we're intending to do. 48, 58, 68, subtract 1 gives us 67. Brilliant. How are we going to do the next one? We'll just pause on that one very, very briefly, have a look at that calculation. What would you do with that one? Hopefully, this is going to practice 2 of the skills that we've been working on this week. 39 is 1 away from 40. So we do 64 add 40 and then subtract the 1. We've now got a number bond from yesterday. 60 and 40 is 100. So 64 and 40 must be 104. Subtract the 1, add 40, subtract 1. That's the strategy we're going to use, and that will give us 103. Now we've got 3 calculations I'd like you to look at now. Again, I want to pause the video, give you the chance to have a look at them, talk to anybody else that's looking at them, or just think about it yourself. How are we going to do that one, and what's the answer? This one, and what's the answer? And again, what sort of strategy are we looking at? And then finally, what does this one look like? How's that going to work, and what's the answer to that one going to be? So pause on those for a second. So the strategy for 46 and 38, we're going to see the 38, it's 2 away from 40, so what we're going to do for that one is we're going to add 40 and subtract 2. So 46 and 40 is 86, subtract 2 equals 84. For 66 add 57, again it's going to end up being very close to being a double, because we're going to add 60 to 66, so we're going to add 60 and subtract 3. So we get 126, subtract 3 is 123. I think we can see now how good this strategy is. That calculation as a partition is quite complicated. 60 and 50 is 110, 6 and 7 is 13, 110 and 13, quite a complicated one. Add 60, subtract 3, much quicker. But it's this one here which really brings this strategy out. Add 97. Imagine what most children are doing at this point. They're immediately, oh, it's big numbers, stick it in a column and start doing a column method. How many children are still doing that in year 4, 5 and 6? What should they do? Recognise straight away, 97 is 3 away from 100. 134, add 100 is 234. Subtract the 3 is 200. I'll write the strategy first. Add 100, subtract 3, and we're going to get 231. Okay. What we're going to do now, just really quickly, is make a couple of those calculations just to prove with base 10 apparatus that the calculation was correct. This one's the 46 and 38. I've made the 46, I'm going to add 40 and subtract 2. So I'm going to put the 40 down there, subtract 1, 2, put those back over here. I can see I've got double 40, but just for efficiency, I'm going to use my 5 and a bit, and I've now got the answer 84. Brilliant. The next one, 66 add 57. Our strategy was to add 60 and subtract 3. This one looks really effective with the apparatus. We're going to add our 60, 10, 20, 30, 40, 50, 60. We're going to subtract 3. That's 1. I'll take 2 of those away, 2, 3. And we can see the answer straight away. We can actually see the 10s together. We've got 2 50s and 2 10s. But what we shall do is exchange those 10 10s for 100. And then we get the answer, 123. Again, quite easy to do in your head, but that's just the visual proof that the method actually works. We're going to finish off on this little part by looking at the final 3 calculations down there. We're moving into year 3, 4, 4, 5, and then into 5, 6. 456 add 199, hopefully fairly straightforward. We add our 200 this time and subtract 1, so we end up with 655. What do we do with this one? 6,837 add 2,998. Again, imagine the time taken, as most children are currently doing in year 4, doing that one as a column method, when all they need to do is spot, oh, it's 2 away from 3,000, let's add 3,000, that gives us 9,837, and subtract 2, 9,835. The same thing even applies with decimals. 6.7 add 2.9. What do we know about 2.9? It's 2 wholes and 9 tenths. It's only 1/10 away from 3, in which case let's just add 3. 6.7 add 3 is 9.7. Subtract our final tenth, and that gets us to 9.6. These 2 calculations look like they're obviously easier than the previous ones we've just been doing. What I want to do with these though is think, is there one way of doing them, or have I got alternate methods? Because we've got 28 which rounds and 39 which also rounds. Similarly, we've got 49 and we've got 98. Again, we'll pause the video, have a look at the calculations and think, actually, are there 3 ways of doing it, and which one would you choose to do? So for each of the calculations, what I've done is shown 2 possible ways to do it. 28 add 39, we could do the add 40 take 1, which is probably the more straightforward way. That gets us to 68, 67. We could swap it around and start with the 39. but use the 28 and round that one. So 39 add 30 is 69 and subtract the 2, which still gets us to 67. But interestingly, what about looking at both numbers? Why not make the 28 into 30, the 39 into 40, which is a much easier calculation, 30 add 40, and then what we're going to do with that one is subtract the 3 at the end. 30 add 40 is 70, subtract 3 equals 67. In a similar way, with 49 and 98, we could make the 98 into 100, that's our rounded one, round it to 100, that's 149, subtract 2 is 147. We could start with the 98, probably wouldn't go for this one, but it would still work. We do 98 add 50 is 148, and subtract the 1 is 147. But again, what about doing both? Make the 49 into a 50, make the 98 into 100, and then we subtract the 3. 150 subtract 3 still gets us to 147.
Again, let's just have a go at a couple ourselves. This time we've got a 2-digit calculation, 29 over 18, and a 2 and 3-digit calculation, 97 plus 398. For each of those calculations, there's potentially 3 ways to find the solution. Do you want to round the first number, the second number, or both numbers? Pause the video, have a quick discussion, prove it all 3 ways. And there we have our possible answers. I would probably, with the first one, have gone for 30 add 20 and subtract 3. I tend to round both numbers wherever possible. With the second one, I'm not sure if possible with that one. I would have just added 400 and subtracted 2 for that one. Alternatively, I may well have rounded both numbers. I think I would probably have gone for just rounding the 398 on the second one. Again, it doesn't really matter. Why not make the 97 into 100? 398, 498, subtract 3 is 495. How much easier are we now finding mental calculation after 3 days of developing different strategies? As we looked at yesterday, the sense of number visual calculation policy, or the MVCP, does have examples of round and adjust. We looked yesterday at the examples of double and adjust, and it does also have many examples for number bonds as well. The examples in the visual calculation policy are, obviously, as mental arithmetic, abstract jottings. We do need to, as we've been showing all day, demonstrate to the children first with apparatus. But what a simple little jotting shows you here is just how to encourage the children to show their working out. How do we do 45 and 9? We add 10, subtract 1. How do we do 4,645 and 1,996? Well, we add 2,000, subtract 4. So we're only adding to the thousands column. 6,645, subtract 4, 6,641. It is, though, really important to note these are just jottings. What we really want children to be doing, certainly by year 4 onwards, is just to be looking at those numbers and being able to do that in their head, rather than having to do the actual jotting.
As always, we're going to have a little spell looking at the ready-made maths number board. Some of these numbers are absolutely perfect for the round and adjust strategy, no matter what number we put them with. 29 just jumps out straight away. If I'm going to add 29 to 42, I'm just going to add 30, 72, and subtract 1. If I'm going to add 29 to 64, again 64 and 30 is 94, subtract 1 is 93. There's going to be some instances where I wouldn't use that strategy. 29 add 10, for example, we'd just add it straight away, or 29 add 11, we'd use the number bond strategy from yesterday. What I want you to do is just, we're going to, again, final time of pausing the video, but we're going to pause the video and just spend 5 minutes or so looking at those numbers and thinking, how many of those numbers would work for round and adjust? Which ones would work all of the time? 29 or possibly 99. And which other numbers might work sometimes and not work other times? Just select maybe 5 pairs of numbers from the board, put them together and design your own round and adjust strategies. And by all means, if you want to send me any examples of your work, that'd be absolutely superb, and obviously I will refer to those in later sessions. So I'll just pause the video now, let's have a look at those numbers.
And what a challenge to complete the day. We've got now a shopping bill of items that over the last few weeks have been quite hard to get hold of. Imagine we're now going shopping, we're going to stock up on some of those difficult to find items. Let's see what the total bill is. How many people top things up as they're going around in the shops? Or do we think, no, we'll just hope the till gets it right at the end? Well, if we can use the round and adjust skill, and actually by the time we get to the end, we can be quite close just with a general rounded price as to how much we think the total shopping bill might be. Let's have a quick look. This is definitely worth thinking about and pausing. What I'm going to ask you to do is to look at every single item. So first of all, think, what would the rounded price be? Secondly, what do I have to adjust? And then thirdly, could you spend maybe 5 or 10 minutes, maybe just 5 minutes, trying to work out the total by using the rounded figures and then adjusting at the end. We'll pause the video now and take some time, have a look at what your total shopping bill price might be. Hopefully, the first thing you've seen is that the eggs round up to £1.50, the bread to £1, and so on. I've looked at the pasta, the chopped tomatoes, and the hand wash separately for each one. The pasta is 79 pence, but we need 3 of them. So we're going to round it to 80 pence times 3, and then we're going to adjust by 3 pence. Similarly, with the tomatoes, because we need 4, we round to 50p, we multiply that by 4, and then we adjust by 4 pence. Finally, with the hand wash, we do the same thing. We, this time, adjust the £1.98 to £2, and we adjust by 3 lots of 2 pence at the end. If we then use our number bonds, we can see the £1.50 is on its own, the bread is £1, we put the £2.40 from the pasta with self-raising flour at £1.60, that's a number bond to £4. The chopped tomatoes are fine at £2, we put the cooking margarine and the caster sugar together, again another number bond, that gives us £3, and finally there's a £6, £12, and another £6. Apart from the £1.50, they're all whole number amounts, so we can add those together relatively quickly. If we add them together, we end up with £35.50. All we need to do then is add together the pennies at the end. If you total those, you get 27 pence. If we subtract 27 pence from 50 pence, we end up with 23 pence. So from £35.50, we end up with a grand total of £35.23 for all of that shopping. Not a bad value whatsoever. You can try this out with any shopping list where the items are obviously got 7s, 8s and 9s at the end and can be rounded up relatively quickly. Give it a go and just see how close you are at the end.
And that's it for day 3 of the Ready-Made Mathematics YouTube Mental Maths training videos. As you know, today we've been looking at round and adjust. I hope you're now beginning to see numbers in a completely different way after 3 days of developing these strategies. Day 1, we're focusing in and homing in on number bonds. Day 2, it was all about doubles and near doubles and using those. Day 3, it's looking at numbers like 29 and 108 and 36 or 48 or 49 and thinking, can we round them and adjust them? If we put all these 3 strategies together with tomorrow's strategy on day 4, then by Friday what we'll hopefully have is a really good repertoire that we'll be able to use again and again and again. Thank you so much for listening. I hope you've enjoyed today's session and I look forward to seeing you all again tomorrow. Thanks very much.
And that brings us to the end of day 3 of the Ready-Made Mathematics Mental Arithmetic Arithme'tricks. We've had a really good time today looking at rounding and adjusting. I hope you've enjoyed the activities. I hope you found the visuals useful. And I hope you're starting to see now how building up this repertoire that I keep mentioning each day is going to start to get us to look at numbers in a different way. And far more importantly, will help us when doing exactly the same thing with children. Tomorrow, on day 4, we are actually going to be looking at 2 strategies together. These are the 2 strategies that we probably use the most often normally for mental calculation, so I thought we'd cover those 2 together. That will allow us on day 5 to bring all 5 strategies into the mix and look at one general strategy that will encompass all of them. Hope you've enjoyed what we've done today. I really look forward to seeing you again tomorrow. Thanks for joining me, and I'll see you tomorrow.